Okay, here's the last problem. And this was just another problem that involved rates and derivatives and integrals. I just wanted to have problems involving those basic concepts and that were in real life situations. And then I wanted to have one that was a table. And in the past, I could just sort of guarantee there, pretty well guaranteed that there'd be one free response problem that required you to work from a table. Now, with only two major questions, we don't really know. But it shouldn't be a shocker to work from a table, and so that's why I wanted this problem, was so you had at least one with a table. All right, so and it's no calculator, so we should be able to do the whole thing. So this is the h of t. The height is given by this, so this is the actual height here, okay? And so this isn't a rate. This is the actual height, not the rate of change of the height, which both the other problems, the functions were given as rates. And they give you the selected values. Use the data table to estimate h prime of 6. So we need to estimate what the derivative is right here. Well, the only way we can do that is by finding the slope of something using the points on the outside and using the data in the table. Like, we're not going to create a function out of this or anything. So how can we do that? Well, why don't we just do the estimate from 3 to 7 and say h prime of 6. Oh no, I'm sorry. Never mind. I'm looking at the wrong place. H prime of 6, which of course is in between these two. So I'll just use these 2 points here. So h prime of 6 is approximately equal to, or can be estimated by, y2 minus y1, 11 minus 6 over x2 minus x1 over 7 minus 5, which is 5 over 2, which is 2.5. And what that's saying is our approximation for the rate the tree is growing. Let's see, 6 stands for years. It doesn't say from when it was born, so I'm just going to say 6 years in is 2.5 units meters per year. Wow. Sheesh. I don't know, that seems kind of fast to me, but this thing is, in 7 years, it got 11 meters tall, so it's getting pretty big here. And I'm just double checking my work. That's right, I was estimating at 6, so 11 minus 6 over 7 minus 5. Yeah, that looks good. Okay. Next one. Explain why there must be some t between 2 and 10 where h prime of t is equal to 2. Now, this one's a little tricky when I first looked at it, because I thought, well, usually when they give you a problem like this, then you can just use the mean value theorem straight off. And that's the idea, is that we've got a point down here at 2, and we've got a point at 10, and it goes from 1.5 to 15. And so a classic problem, when they do this in a classic way, they just give you the exact slope here, and you find the slope of this and use mean value theorem. Well, the problem is that's not what the slope is. The slope here is 13.5 over 8 is the slope between those 2 points. And that's not 2, so I can't just assume it based on those two. But they did say it was twice differentiable. So I've got two possibilities here. One possibility that I could do is I could find what the slopes were and show that there was a time when the slope was above that, and there was a time when the slope was below that. And since it's twice differentiable, that means the slope is changing gradually, and somewhere in between the slope would be 2. But I did notice that between these 2 points, the slope is actually 2. I spotted that one. And so that seems like, well, okay, that's the easier way to go. And so that was for A. So for B, okay. For B, the slope, or, well, let me see. I just want to write things correctly here. So we'll say that h of, make sure I have the right points. This is h of, maybe I should shrink it up. That would make it easier. H of 5 minus h of 3 over 5 minus 3 equals h of 5, which is 6, minus 2 over 2, which is 2. And so now we know that because the slope here between those 2 points is 2, that means that between the 2 points, that means somewhere in between, there's a moment when the slope is 2. So by the mean value theorem, and MVT is accepted by people, by the mean value theorem, there is a moment, and it could be more, it doesn't say only one, there is a moment for t between 2 and, between 3 and 5, where h prime of t equals 2. Because the average slope is 2, that means there's a moment where the instantaneous slope is 2. That's the mean value theorem. And since there's a moment between 3 and 5, therefore there's a moment between 2 and 10, because between 3 and 5 it'll happen. Moment where h prime of t equals 2 between 3 and 5. Okay, I feel like I'm getting a little long-winded. Oh no, wait, I'm sorry. I already said that, and it's between 2 and 10. Okay. So now the next one is a trapezoidal rule, and we have to you do it to find the average value. Because I'd be scrolling back and forth, I'm going to pause it and write out the formula. I figured out a way to do it, and I've opened the problem next door so I can quickly get the values here. But and so I said the average height is, and so if this is the average value of a function, and the average, well, I can't highlight there, and the average value of a function is the integral of the function times 1 over b minus a. So that's my setup for the average y value, in this case the average height. And that's the mean value theorem for integrals. So it's 1/8 times this one, which is approximately equal to, and now I'm going to do my trapezoidal rule. What was interesting in terms of trapezoidal rule is that because the width is not the same when you look at the table over here on the left, sorry, I don't think it's showing up at all. Well, maybe it is. So when you look at these, the widths are not the same. You can't generate it with one formula where you do the width first, b minus a over 2n, and then have 1, 2, 2, 2, 2, 2, 2, 2, 1. I can review what I'm talking about if that seems weird. So instead, to do trapezoidal rule here, I'm just going to have to do each trapezoid. So the first trapezoid, the formula for each one is the height. Ooh, man, there, yeah, it's the height times base 1 plus base 2 over 2 times the average of the two bases. Now keep in mind, when we talk about height here in bases, we're doing a trapezoid that looks like this. So the height is actually the width of the trapezoid as we look at it this way, and the two bases are these vertical lines. So in this case, it would be, to do that, it would be the height is 1 times, and it's base 1 plus base 2 over 2 plus the next one. Yep, the next one, which has the height of 2, and the two bases are 2 and 6, so that's 2 plus 6 over 2 plus the next one, which is the height is still 2 times 6 plus 11 over 2, averaging the two bases, plus the last one, which has a width of 3, and then times 11 plus 15 over 2. Remember that if you write a numerical expression for an answer, as long as you write it correctly, I had to close my parentheses I started at the beginning, you can leave it like that so the computations don't mess you up. I mean, if I needed this for something later, that'd be a problem, and maybe I will have to work it out. But for right now, I would skip it, and I would just move on to the next question instead. And, oh, whoops, I put it, oh, wait, something's gone crazy here. Oh, I put it right there. That's kind of funny. All right, so that was the end of this problem. Somehow I put it in the wrong place. That was kind of crazy. All right, Now I'm just going to go to D though, because you've seen the answer, so it doesn't matter where I wrote it. Last one, the height of the tree can also be modeled by function g given by that. So now they're giving us, instead of the table, now they're saying, can you do processes with this thing if I give you a function instead? Okay, where x is the diameter of the base of the tree. Okay, so this is giving you the height based on the diameter. Okay, when the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. And now what is the rate of change? So they give me one rate of change and they're asking me another rate of change. Anybody catch what this is? This is a related rate problem. So I've got something that's relating I've got an expression, I've got an equation that uses my variables. And so now I can say dg dt equals the derivative of the other side, but I'm taking the derivative with respect to time, not x. X is the diameter of the base. So it's low 1 plus x, d high, which is 100 times dx dt, minus high 100x, d low, which would just be 1, except it's 1 dx dt, over low, which is 1 plus x squared. Okay, according to this model, what is the rate of change of the height of the tree when at the time when the tree is 50 meters tall? Okay, well, I mean, what do we need? We got the rate of change. So what is the rate of change of the height of the tree? There it is. And I've got dx dt, which is just going to be 0.03 because they gave me that. And then, but I need to find what my x is. I need the diameter. Oh, but they gave me this function. I can figure out what the diameter is. So I could plug in, don't know how to make that go away. That worked. I could plug in 0.03 for my dx dt's, but I need to plug in for x. And the way I do that is by solving this equation. So 100x over 1 plus x has to give me 50 meters because we want it when it's 50 meters tall. And so I have to solve for x here. So 100x equals 50 plus 50x. So subtract it over, is it that easy? 50x equals 50, so x equals 1. Let me double check that. 100 over 2 is 50. Oh, you guys are nice. So x is 1. So you plug in 1 for the x's. So you plug in 1 for the x's and 0.03 for the dx dt's, and then leave it at that point because you don't want to do any algebra because you don't need to once you have that expression done. So I've got 2 minutes. I can make it. And so, but I'm out of room. So for right now, because it is legal, I can just say I had this equation and that told me that x equals 1. So dg dt is equal to 200 times 0.03 minus, plug in 100 times 0.03 all over 2 squared. Oh, that's nice. So it's 100 times 0.03 divided by 4. So that's 25 times 0.03, which is 0.75 units. This is the rate of change of the height of the tree. This would be in meters per year. This is when x is equal to 1. Oh, this is based on diameter. I was trying to go back to the table if I could, but I can't because it's unrelated to the table, because the table is about years and meters as opposed to height and diameter. Oh, wait a minute. So it's not meters per year. It is meters per year because it's dg dt. That makes sense. Okay, I'm out of time. Hope this was enjoyable. That was fun for me.